let's look at an example of checking the speed of a car. Now, let's say, assume this is observer. That is a place with a radar gun. The police send out a signal frequency f of o. Well, if it's a radar gun that travels at a certain kind of speed, that is the speed of electromagnetic waves. But anyway, this v means speed of wave. Okay. Now there's a car travel towards the observer with v of c, means v car. What will the frequency receive by this observer? There's two steps. Step number one, imagine that a signal of original frequency fo traveled at the speed of source of v. I'm sorry, this is the speed of the wave as v. Right now, who is the source? Source is this guy, is the observer itself. It doesn't move, it is at rest. Now, from the point of driver's view, that right now the driver actually is the observer. What will the frequency the driver receives? The frequency driver receives, well, follows this equation. F of new equals to f of original. Right now, this is source. Source does not move. This is observer. Observer move towards. So observer move towards is a plus. Source does not move. So that is the result. This is the frequency received by the car driver. A signal hit the surface of the car, bounce back. That doesn't cause the change of frequency. So right now, a signal of f prime emitted by the car, which is reflected on the surface of the car. Well, since the car is moving to the left with a v car, so this is as if you have a source moving to the left with a vc emitting f prime, such a signal. Now, this is the observer. So this observer will receive a f prime frequency because the signal from the car is f prime already. But the source as the car is moving towards the observer. So therefore, the new frequency is based on the frequency sent by the car. Car is the source right now. Source is moved towards. Observer does not move. Observer does not move. Source is moved towards, you receive a higher frequency, you choose minus. Minus what? Source is the car. So it's that. Now we know that for the first step, the f prime is the frequency received by the car. It's coming from here. So we're replaced by f of o, v plus v of car over v, and here is the rest of it. So the result comes out as this v cancels. We have the new frequency received by this observer is v plus vc, and v divided by v minus of vc. This is the frequency received by the observer. So for example, if the observer knows exactly what's the original frequency, and now this is the new frequency, and by using this equation, and we can have a program calculated by computer, we can find what's the speed of car. And if this is a zoom with speed limit, we can immediately compare with that speed limit. If it's beyond that, then this car is speeding. So if this observer is a police officer, he might issue a speeding ticket to this car driver. Now let's talk about a very common situation called shock waves. A so-called shock wave is when the source travels so fast, it travels faster than the wave spread. For example, at t equal to 0, source is here. During t second, the source has already experienced S1 position, S2 position, S3 position, until the Sm position. So the source travel distance S of source time t. That is very far. During the same time, t, that the first position when the source is at t equals 0, the wavefront only traveled at certain speed of the wave time t. It's only traveled this much. It's less. So let's look at our Doppler effect situation, that new frequency equals to original frequency. In this case, concerned about source travel. Now, if source travel faster than speed of the wave, and then if you choose a minus sign, we will have a problem with the entire result is negative. New frequency is negative, doesn't make sense. So when the source travels faster than the spread of wave, we do not temporarily consider about this Doppler effect situation. We look at this so-called Shockwave situation. A shock wave, a series of wavefront, will shape such a interesting a triangle shape, and that this angle of alpha can be calculated. As a matter of fact, this is 90 degrees angle. So from S of O to S at N, this is the hypotenuse of the right-angled triangle. So if we use a sine of alpha, that is sine of opposite VT divided by hypotenuse, which is Vs of t, and the time interval cancels, that we can, as a matter of fact, either we know this angle, we can find how fast the source travel, or as a matter of fact, we know how fast the source travel, vice versa, we can find this angle. So this is a very interesting situation. If you remember, if we have a boat, mechanical boat, travel very fast on the lake, well, the surface wave expressed through the two-dimensional wave surface is relatively slow. That is the v, speed of wave spread on the surface of the lake. Well, the boat traveled very fast. The boat caused the vibration. Boat is the source. This is a situation that source travels faster than the wave spread. So you actually probably already encountered this situation. You will see a trail of the wave followed by the boat. And that is so-called shock wave, visible shock wave. And if you take a picture of it and measure the angle, and you will be able to find the speed of the boat. Well, speed of the wave spreads through the water can be very easily measured. For example, if you get a bathtub filled with water, and if you get a stopwatch, and if you disturb the water, watch how fast the wave is spread to the other side of bathtub. You get the time, you know the distance the wave traveled, you can find the speed of the wave spread through the surface of the water. And then from measurement of the angle from the photo, you can get calculation about how fast this boat really travels. If this is airplane, which travel a supersonic speed, which may travel faster than the speed of sound, then you will hear sonic boom. This is a so-called shock wave. Let's look at a sound level problem. Sound level defined as SL in decibel equals to 10 log the intensity at that particular location due to the sound waves divided by the reference intensity I0. The reference intensity I0 is the threshold of human ear's hearing. That is at intensity of 10 to negative 12 watt per meter square. Say there's a room of sound level 30 decibel without any students. Now, with 50 students taking exam, assume that all of them are identical. Then the sound level SL2 is 50 decibel. Now the question is, what if I have only 25 students in the room and taking an exam? What will be the sound level? So that is SL of 3, which is unknown. How do we solve this problem? Well, let's take a look at the definition. SL1 which is 30 decibel, comes from of 10 log of I room only over I of reference. Now SL2, as a matter of fact, is 50 decibel, and which comes from, now remember, intensity is every meter square how many watts, so it should linearly add to each other. So that is the room intensity plus 50 identical students of each of them is I of S. That is the total intensity which produce that 50 decibel. Now what we want is obviously what I of room plus 25 IS over I of R. So it looks like as long as we solve what is the value for I of S, and then we will be able to find the answer for SL3. So it is pretty easy that we can get that from I of the room from here by both sides dividing of 10, you get 3, and 10 to the 3 then equals to I of the room over I of naught. And the other one, both sides divided by 10, you get 5, and 10 to the 5 equals to that I of the room plus 50 of I of a student over IO. So actually we can take ratio of this equation to solve what is IS. Therefore, this is a case of 10 log. Once we get I of room from here, and then that actually you can use I room is 10 to the 3 of I naught, and plus 25 of I of S over of I naught. Actually, we can express all of I of room and I of S in terms of IO, because if you take a look here, that we get I of room is 10 to the 3 of I naught, and here that you get 10 to the 5 I naught, and then subtract of I of room, and then divide by 50, that you get I of S. So therefore you can replace I of room as 10 to the 3 I naught, and here plus 25 of I of student, which has a 50 as denominator, and 10 to the 5 I naught minus I of the room. I room 10 to the 3 of I of naught. So everything is with respect to the I naught, and then I naught cancels, and it's very easy to get the answer for a 25 student within a room.